Hello everyone, we're on lesson number 5, multiple angle and product to sum formulas. So you might see right here it says that you need the helpful trig formula sheet and a unit circle. So if you don't have this from last time, I want you to go to Unit 5 documents, print this out, you're going to need it, and get yourself a unit circle as well. I'm going to pause the video, or you should pause the video, and resume when you have all that ready to go. Alright, so on our sheet, we're going to be working with these top pieces: double angle, power reducing, half angle, product to sum, and sum to product, right up to this first line. That's all the stuff that we're going to be using for this lesson. And right off the bat, I'm noticing that I have sine 2x minus sine equals 0. We're asked to solve. 2x, that's double, right? Anytime you multiply by 2 is double. So we're using these formulas here. Okay, I'm working with sine here, right? Sine. So this is the formula we're going to use. So we're going to use that formula to change the sine of 2x. That's going to become 2 sine x times cosine of x. This minus sine of x never changed, and equal to 0 has never changed. So far we just used the double angle formula to change this. I'm changing that, which is good because I can factor out a sine of x. That's going to leave me with 2 cosine of x minus 1, right? If I pull a sine out from there, that's equal to 1. And at this point, it's just like all the other problems we've been doing in this unit, right? We're going to set each piece equal to 0 and solve, and then check out the unit circle, right? Sine of x equals 0. So we want to look at our unit circle and figure out where sine, which is y, equals 0. So sine is 0 here at 0 or 2 pi, and sine is equal to 0 here at pi. So that one was pretty quick, right? We found 0, pi, and 2 pi here. This one we've got to solve for. I'm going to add 1 to both sides, then divide by 2. So now we're looking at the unit circle for where cosine is 1/2. Remember, cosine is x. So I see it happening up here. X is 1/2 at pi over 3. And we get x as 1/2 at 5 pi over 3. So those are our answers for cosine of 1/2. Right, pi over 3 and 5 pi over 3. So those are our answers, right? 0, pi over 3, pi, 5 pi over 3, and 2 pi. Right, so quick recap, right? We used the double angle formula right at the very beginning. We only had one option here. We noticed that we could factor out a sine, which allowed us to solve for each piece individually. We got each solution by looking at the unit circle real quick. Those were our answers, right? Really, same stuff that we've been doing mostly the whole time. Now we're just using a couple of formulas to help us out. So you've got one for yourself to try. Just be aware, this problem calls for double angle formula for cosine, and you have 3 to choose from. What you should notice is that you have a cosine here. So which one of these do you want to use? You want the one that's going to be working with just cosines. That's my hint to you. So pause this video and resume when you're ready to check your solution. Alright, so I gave you a hint. I said that you want to use, of these formulas, the one that keeps only cosines, and that had to do with what we started with. So looking here, right, sine squared, that gives me a sine back in there. Probably not going to want to use that. Down here, 1 minus sine squared, they don't even give us cosine here. So this is the formula that we're going to want to use. Okay, that cosine squared minus 1. Right, so here's what we've got. 2 cosine squared x minus 1. That's the double angle formula gives us here. and then we still have plus cosine of x equal to 0. Hopefully you noticed that if we were to rearrange this, we'd have a quadratic. Why is that good news? Oops, that's minus. Why is that good news? Because if I was to look at these in just terms of x, I can now factor, right? I know I have to have a 2x and an x, and I know I'm going to have a 1 and a 1 in order to get a 1 here. The question is, what should be positive, what should be negative? Well, I want the bigger one to be positive. So 2 times 1, when I do my foiling here, that's going to give me positive 2x. So that means that has to be negative positive 2 minus 1. So that works out. That's how we factor here. We're going to change this back to cosines. Sorry, that's a little blurry. Okay, so once we have this factored, now we're actually in really a good position to solve, right? We're going to set each of these equal to 0. I'm going to have to add one here. Oops. Divide by 2. So our first solution, we're looking for wherever cosine equals 1/2. We actually found that in the last problem, right? We found cosine of 1/2, cosine of x equals 1/2 at pi over 3 and 5 pi over 3. It's the same thing here, right? So we have these solutions, pi over 3 and 5 pi over 3. That was pretty easy. Now we've got cosine of x plus 1 equals 0. If I subtract 1 from both sides, we're looking at our unit circle for where cosine equals -1. Remember, cosine is x. So looking at our unit circle, we see x equals -1 at pi. So here you only had 3 solutions. You had pi over 3, pi, and 5 pi over 3. I hope you got all 3 of those solutions. The trickiest part to me was figuring out which of these double angle formulas to use. Right? I used this as a hint. The next trickiest part is factoring, or recognizing even that you can factor. Once you get to here, it's cakewalk, right? You just do what we've been doing the whole time. So let's check out some other problems. Okay. The next problem that they ask us is going to be rewriting sine squared x, cosine squared x in terms of cosine to the first power. So we have a power of 2 and we're trying to change it to a power of 1. That's reducing. That's power reducing, which luckily we have formulas for, right? Power reducing. Sine squared gives us this 1 minus cosine 2u over 2. Cosine gives us 1 plus cosine 2u over 2. I need each of these because both of them show up in our problem. Right, so I'm going to use that first one, sine squared x. That gives us 1 minus cosine of 2x divided by 2. Cosine squared gives us 1 plus cosine of 2x divided by 2. Okay. Let's see, 1 times 1 on top. That's 1. 1 times cosine is positive cosine. Negative cosine times 1 is minus cosine. So those are going to cancel. And then we've got minus cosine squared of 2x because we have 2 of those things multiplying each other. And then on bottom we have 2 times 2, which is 4. So we're actually not in bad shape. We started with a sine and we got rid of it, which we needed to do because we only want cosines. But now we have a cosine squared again. So we're going to have to use this formula, right? Cosine gave us some new pieces here, right? So we're going to have to work with that. As 1 hasn't changed and we still have minus, I'm going to have to use this formula again. So this time we have 1 plus cosine of 4x. Remember, we doubled when we went from here to here. So now we're going to have to double going from here to here. Okay, that's why that became a 4. And we're over 2. And this whole thing is over 4. Now this isn't the greatest in the world. I have a positive 1 here, and I have a denominator of 2. So I'm going to have to change this 1 into a 2 over 2 in order for me to do that subtraction. So 2 over 2 minus 1 plus cosine of 4x over 2 all over 4. Now here's something that you might miss. And this is easy to miss because of the fact that we have this ugly looking fraction function thing happening here. This negative has to distribute to both terms. And that's easy to miss because we're not used to working with something as funky looking as this. So we have to make sure that when we do our subtraction that negative sign hits both of those values. So we've got 2 minus 1 minus cosine of 4x. Now we have the same denominator, so over 2, all divided by 4. Now it's getting a little bit cleaner, right? 2 minus 1 we can simplify to 1 minus cosine of 4x divided by 2. And instead of dividing by 4, I'm going to multiply by the reciprocal, right? That's how dividing by fractions works anyways, so that's a good idea. This top piece, this whole thing, we're multiplying by 1. So this is going to stay the same. And on bottom, we have 2 times 4, which is 8. I can't simplify that any further. That is power reduced, right? We went from having a power of 2 to begin with. Now we have it in cosines with power of 1. So objection accomplished. I don't have any practice problems of those for you to do. They're you don't see them too often in the wild anyway. So let's move on to the next type of problem. These problems are asking us to find the exact value of sine of 165. Now, if our unit circle had that there, we would just look at the answer and we're done. Unfortunately, that's not the case. And even worse is that we can't necessarily just add and subtract values from the unit circle to get 165. Nothing really easy pops up. So we're going to have to use some of these half-angle formulas. How did I know half-angle? Because what I need to think about, if I can't add and subtract to get that value, now I have to start thinking about, all right, well, is it, a multiple of something that shows up? And in fact, it is. 165 is equal to half of 330. 330 appears on the unit circle. So this is something that we want. And according to our half-angle formulas, we're working with sine here. I want plus or minus the square root of 1 minus cosine of u over 2. So we're going to change sine. Really, it's going to change into a cosine here, right? 1 minus cosine of u. This is u, right? Because we're doing half of u to get that 165. So we're working with 330. And that's divided by 2 here. Okay? Now we're going to do a little bit of simplifying, right? If we look at the unit circle, 330 degrees over here, we got root 3 over 2 and negative 1/2. That's for 330. Cosine is x, so we've got root 3 over 2. I'm just substituting in the value here. Still dividing by 2, all still under that radical. Well, 1 minus this, I need this to become a 2 over 2 in order for us to do that subtraction. And we're still dividing that whole thing by 2. And it's all still under the radical. Now we can do the subtraction. right? Plus or minus square root of 2 minus root 3 over 2. Okay, it's getting a little bit simpler and simpler as we go along. Instead of dividing by 2, I'm going to multiply this top piece by the reciprocal of 2. So that's 1 over 2. Alright, so if I have something on top times 1, none of the stuff on top is going to change. So 2 minus root 3. 2 times 2 down here, that's going to give us 4. And hopefully you remember from radical functions, I'm going to break this square root up. So it's going to go away. I'm going to have the square root of this whole thing on top and square root of the thing on bottom. That's good news, right? Square root of 4 is going to be 2, and the square root up here isn't going to change. 2 minus root 3, all in the radical. And that's it. That is the exact value. No decimals. We're not rounding anywhere. This is the full solution to sine of 165. If you were to take a calculator in degree mode and type this in, and then you were to take a calculator and punch this in, you'd find you get the same exact thing. Same value. So we've got one for you to try. This is going to be a half angle formula. If you notice, this problem says tan. Tan gives you two formulas to work with. You can use either of these formulas, right? You can use either one. I'm going to use this bottom one. So if you want to end up following along with it, use the bottom, but it's completely up to you. Pause the video and try this one out. Alright, let's check out how you did. I gave you an easy value to work with. Excuse me. 22.5. That's half of 45. So this is our U value that we want to use. Tan of 22.5. According to the half angle formula, I use the bottom one. Right? They give us sine of U, which is 45, divided by 1 plus cosine of U. Right, so again, I use this bottom formula. You could have used the top. I'm using the bottom. Doesn't really matter. You'll get the same answer. So looking at our unit circle, at 45 degrees, we find root 2 over 2 and root 2 over 2 for cosine and sine. And I'm going to plug those in, or substitute those values in. In order for me to do my addition, we've got to change that 1 into a 2 over 2. Now we can add. So we've got root 2 over 2 divided by 2 plus root 2 over 2. At this point, I have a fraction divided by a fraction. Let's multiply by the reciprocal. So root 2 over 2 times, we got to flip this, so 2 over 2 plus root 2. Wow, that's a lot of 2's. Anyways, we can notice that some of the stuff on the fractions will cancel each other out. So we've got root 2 over 2 plus root 2. Now you might have gotten here and thought you were done, but unfortunately we can't have a radical on bottom. And if you remember from last lesson, we have things called conjugates. So I'm going to use that. It's the same binomial, but we just want a different sign in between, and that's going to help eliminate these squared roots that we have. And I'll show you why in a second. Okay. Here we have root 2 times 2, so that's 2 root 2. And then we have root 2 times negative root 2, so that's minus root 2 squared. Down here we have 2 times 2, which is 4. And this is why we're using a conjugate. 2 times negative root 2. That's negative 2 root 2. Positive 2, positive root 2 times positive 2. So that's positive 2 root 2. So we had a negative 2 root 2 and now a positive 2 root 2. That cancels out. And we've got positive times negative. So minus root 2 squared. Watch what happens to all of our radicals. Right? That goes away on top, leaving us with 2. But more importantly, the radical on bottom goes away. So what do we have? We have 2 root 2 minus 2, right? Those radical and squares canceled. And then we've got 4 minus 2. We're almost done. I've got a 2 on the top here and here that I can factor out. So we've got 2 times root 2 minus 1. And then 4 minus 2 is 2. I set it up that way on purpose because I can see that my 2's cancel. And our final solution is square root of 2 minus 1. That was not super difficult, but again, there are some things that we have to keep in mind from last lesson, right? If we have a radical on bottom, we need to use conjugates. So you might have gotten to here and thought you were done, but we're not quite as simplified as we can get. This is the answer we were looking for. We're going into some slightly easier problems, I think. The sum and difference formulas, which we see here, product to sum. Okay, we want to be looking at these ones. Now, they want us to rewrite as a sum or a difference, and they're giving us cosine and cosine. We'll call this u, and we'll call this v. So, product to sum using cosine and cosine. Here's the formula that we want to switch to. It's saying 1/2 cosine of u minus v plus cosine of u plus v. So we already established that these are our u and v values. So all we have to do is just plug in to our formula. Right, 1/2 times cosine of u, which is 6x, minus v, which is 2x, plus cosine of u, again that's 6x, plus v this time, which is 2x. So all I've done is just replace each of these values into the formula. Now I have to just simplify. 1/2 times cosine of, let's see, that's 4x, plus cosine, that's going to give us 8x. That's it. That's our answer. It just said to rewrite as a sum or difference. That sum, that's all they're asking for. Okay, so you have one to try on your own. You're rewriting cosine of 5x times sine of 3x as a sum or difference. Make sure that you use the correct formula here. Pause the video and resume when you're ready to check. Alright, let's check that out. So we had cosine times sine. So when we're looking at these product to sums, we want cosine times sine. So the formula we want is right here. It says 1/2 sine of u plus v minus sine of u minus v. This is u, this is v. Sine of u 5x plus v, which is 3x, minus sine of u minus v. Right, just plugging in those values into the formula. That 1/2 hasn't been touched yet. 5 plus 3 is 8x. 5 minus 3, that's 2x. And that's as simplified as that one's going to get. Hopefully you got that one. Those are nice, easy problems to do. You're just plugging in right into that formula. We got one more type of problems left to do for this video. It's getting long enough as it is, so it's a good thing that we're to the last two. These problems are asking us to find the exact value. Okay, we can do that. And what we should notice is that we have a difference. Well, if we look at some of these formulas down here, sum to product, we notice that we do have differences here, right? We have sine minus sine, which matches with what our problem gives us, right? Sine minus sine. So we're going to want to use this formula down here, which calls for 2 times cosine of u plus v divided by 2 times sine of u minus v divided by 2. This formula, that's what we're using. Here's u, here's v. So 2 cosine u, which is 225, plus v, which is 135, divided by 2, times sine of u minus v divided by 2. Right, just plugging into the formula. It's pretty simple. So let's see, 225 plus 125, that's going to be 360. 225 minus 135, that gives us 90. 360 divided by 2, that's 180. 90 divided by 2 is 45. So we've got some values. They're asking us for the exact value. So we need the unit circle. At 180 degrees, cosine, which is x, is -1. So let's see, 2 times -1. Sine of 45. Here's 45. Sine is y, so we get root 2 over 2. And now we can start crossing some stuff off here, right? Times 2 and divided by 2, those cancel. So we've got -1 times root 2. Negative root 2 is our answer. That's the exact value of sine 225 minus 135. So you've got one more problem to go before this video is over. Try this out on your own. Make sure you're using the correct formula. Pause the video and resume when you're ready to check your solution. Alright, here it is. We have cosine plus cosine. So when we look to our formula sheet, we want to use this one, cosine plus cosine. So it's 2 times cosine of u plus v over 2 times cosine of u minus v over 2. Here's u, here's v. We still need that unit circle, so I've got it handy on my phone ready to go. So here, 2 cosine of u plus v over 2 times cosine of u minus v over 2. Right, those are the formulas that they give us. 270 plus 30, that's going to be 300 divided by 2. 270 minus 30 is 240 divided by 2. Half of 300 is 150. Half of 240 is 120. So we need to look for cosine of 150 on the unit circle. 150 cosine is x, so negative root 3 over 2. So we've got 2 times negative 3 root 3 over 2. 120. 120 is right here. That's -1/2. And now we got some stuff that's going to go away, right? Negative times negative, those are going to end up canceling each other out. 2 times divided by 2, those cancel each other out. So we've got positive root 3 times positive 1, so root 3. And we've got 1 times 2, which is 2. That is the exact value of cosine 270 plus cosine of 30 degrees. Not a bad lesson. Yeah, it's a lot of formulas, but if you use the right formulas, they're actually pretty simple problems, right? These are the formulas we use today. We've gone through a lot of trig in this unit, and you have completed Unit 5 at this point. So if you have questions, bring them into class. I'll answer them there. I guess you could leave them in the comment section if you want. Maybe somebody in the internet lands can help us out. Until then, I'll see you at unit number 6. Bye.